We can start the session with the second presentation. We had in meantime chance to see the very interesting presentation about digital fabrication of concrete structures given by Jane Mata-Falcon. And now we have a second presentation of the session, and it will be given by Thomas Scherer from Technical University of Kaiserslautern. And it will be about sealing of service penetrations in timber buildings with the method wood in wood. So I would like to ask if Thomas is prepared for the start of presentation.
Yes, I am.
Okay, perfect. And so you have welcome, and you have about 15 minutes for your presentation, and then we will start discussion about 10 minutes. And I would like to ask also all other participants if you like to ask something. So at the bottom you can through chat or question and answers to raise some questions, and I will read it, and Thomas will answer these questions. So Thomas, you can start.
Thank you for introducing, and good afternoon to everyone. So my topic is sealing of service penetrations in timber buildings, and I want to present a kind of new approach today. So first I want to go into the basics, a bit about timber building and about service penetrations. Then I come to the state of the art regarding penetration sealing in wood building. How is the approach worldwide right now, and the special case Germany just a little bit. Then I go to the tests we did so far and a few results, and in the end I have a short conclusion. So wood as a construction material becomes more and more relevant. That's because of ecological aspects, as it is a renewable resource, as we all know, and it's a carbon dioxide sink, as it captures carbon dioxide when trees grow. And there are some economical aspects too, why wood is used. That overall the prefabrication, the components for timber buildings can prepared in the works and then be transported to the construction site and then put together on site. That enables really short building times, and on top it's a light but strong material, so it can be used for post compressions in urban areas, or sometimes it can enable buildings to stand on soft grounds where other materials like concrete or steel can't be used. And that that makes that today higher timber buildings are built than before, and that leads to new challenges, because tall timber buildings demand higher fire safety requirement. It's harder for the fire brigade to extinguish higher buildings, and as wood is a burning material, it's harder to extinguish because the building components themselves burn, and so sectioning of the buildings in smaller parts becomes more relevant. And there come the penetration sealing into the game. Always when a separating component like a wall or ceiling is penetrated by conduits, cables or pipes, the holes must be sealed in equal quality to the fire resistance of the building component. In higher buildings and in modern buildings, more technical equipment is used, and so we get more and bigger penetrations. That's why the penetration seals get more and more relevant. So the problem is right now worldwide, most products for penetration sealing miss approval for the use in wood. And yeah, that's why a big number of products need approvals and tests for the use in wood. But there are many different sealing systems and a lot of different timber assemblies, and that would therefore there would be a lot of tests needed. But actual research shows that a lot of known systems can be used in wood. But right now, the approach is to use the known systems in the wooden buildings within a massive component made of concrete, and so it's not a direct use of the sealing systems in the wood, as it would be easy and lead to a fast construction. So it's a step where wood is substituted in the area of the penetration. And in Germany, there's a special aspect. So if you put a hole into a timber component, you have to line the penetration. So you have to line the opening area that the fire can't get into the opening, and there can be no fire in cavities. Yeah, so there would be a lot of tests needed to prove the use of the sealing systems in all different timber assemblies where they could be installed. And so now our idea was to find a defined timber module in which penetration seals can be used and tested very well, and then these defined modules can be put into different timber wall assemblies and different constructions. So how are sealing penetrations tested? It's tested according to the standard norm for fire systems testing, this one, and there's a special standard for penetration sealing testing. The penetration seals are put into standard components of walls or sealing assemblies, and then they are put into the testing oven, the testing furnace. Here you can see a small testing furnace, as we have one at TU Kaiserslautern, and here is our big testing furnace. There can components from the dimensions of 3 × 3 meters or ceilings 3 × 4 meters be tested. The sealing systems are installed in that component. Inside the oven, the heat curve, the ISO heat curve represents the room fire, and the building component is exposed to that heat. So outside, the measurements are made on the components. We measure the integrity and the insulation criteria. For integrity criteria, no flames may occur on the outside of the component, on the cold side, and no big gaps may occur, and a cotton wool which is placed upon the surface may not ignite. For the insulation criteria, no temperature difference of more than 180 degrees may be reached on the outside of the component. In our research project, which is finished right now, we first tested failure mechanisms of surface penetrations in different timber modules. So we tested a massive module of glulam, and we had a second module of oriented strand boards and mineral wool. And it came out that the massive module was much better because it just had no cavities and the fire couldn't spread that much inside the module. After that, we put our modules into different wall constructions, a massive wall construction from CLT, and another construction from another frame, a timber wall frame construction. We put inside there our modules, and we tested if our method to put the modules into the different constructions worked out. And yeah, our method worked. So that was the foundation, and then I got on with further research in these modules, and that is where I want to focus on today. So this is the test setup for the further research we did so far. I put wall components of 60 millimeters of glulam into the small test furnace. We put single cables and pipes through it and sealed it with different sealants. Inside the oven, the isocurve was heated. That's the test setup inside the oven, and that's how it looks when it's burning inside the oven. On the outside, temperature were measured at these 2 points. One measure point was always on the line, 25 millimeters away from the component surface, and the other measure point was 25 millimeters on the component surface above the line. And we checked the integrity and the insulation criteria as well. So this was the detailed test setup. We had the glulam modules, and we had different pipes and cables. So we had small and bigger copper pipes, which are represented by the red dots, and we had single cables and cable bundles, which are represented by the green dots, and we had different sealants. So yeah, the lines were sealed either with gypsum, stone wool, or 2 sealings from Hilti, 1 acrylic fire stop filler and an intumescent cork. So first I want to go into the results from temperature measurement. The oven was heated for 30 minutes, and so we have the heat curves here. The red lines represent the average temperatures we measured on the copper pipes. The upper line is the thicker pipe, and the lower line is the smaller pipe, but you can see it's really high temperatures on the copper pipe outside the oven. So there would be additional measures needed to prevent the ignition of components or items on the cold side. The blue lines showed temperature on the wooden surface above the line, and as you can see, it's in average below 100 degrees, and as the temperature criteria would allow 180 degrees, that's quite safe, and there's no problem with fire spread over the wooden surface. On the cables, we had much lower temperatures. It's quite the same temperature on cables and cable bundles, about 150 degrees of temperature difference on the outside. So it would be possible to lead cables through the wooden components just by sealing it in this way. Yeah, all the sealants maintained the integrity criteria for the whole test. So there were no flames occurring on the outside, and there were no big gaps that the gauges can be put through. Yeah, but the high temperatures on the pipes are a real problem. Yeah, after the tests, the specimens looked like this. The copper pipes were quite the same. The cables have no insulation, and here you can see the coal tiles. After that, removed the lines, and we scratched away the char layer. Yeah, to investigate that nearer. We cut through all the holes in the middle that we can see the charring and the color inside the holes. And yeah, here on the side you can see which penetrations were in each hole. So this one, the cable with acrylic sealant represents this hole, and so on. This one is this, and the stone wall with cable is this one. So you can see that the cable penetration with different sealings leads to really different charring or blackening of the drilling hole. So here it's not charred and not even black, and here it's fully black. As an example, here it's really charred through the whole section, and here it's just blackened or charred, but it's still a straight drilling edge which can be seen. Yeah, so the conductivity and the combustibility of the lines influence the charring and of the boreholes, and so does conductivity, heat capacity, and reaction to fire of the sealant which is used. That's what we can get as a conclusion so far from this. If I want to go deeper with respect to time, I can't talk about it much more today. So I come to the conclusion. So from our research project, we can say that the use of sealing systems installed in wood is possible. So the direct installation without the substitution in the penetration area with concrete, and the sealing within timber modules can be a solution for Germany, and I think it can be a solution for other countries as well. And for single cables and pipes, there can be facilitations to define which can be a safe and cheaper way to go. And the charring in the boreholes can give further information about which sealant is applicable for the conduit penetration. So that was all from me. Thank you for your attention, and now I'm happy to answer to questions.
So thank you very much, Thomas. It was a very interesting presentation of the research. So we will start with the discussion. So maybe I will have just a very simple question from the beginning. So as I understood, so you expect that the wall is designed for 30 minutes, yes?
In the last experiment, yeah, this wall was designed for about 30 minutes, yes.
Okay. And what was? Did you measure the temperature on the not exposed side of the wall during the experiment? I mean, on the surface of the wall.
I did an extra experiment for this. They had a component of this wood without penetrations, and I measured the temperature on the unpenetrated component. Okay.
And the last, now just I wonder, you showed when there was a cable or the tube in the hole. Yes, exactly. So this irregularity of the position. So it was made because you wanted to have this irregularity to have different ceilings, or what was the idea in this?
Yeah, that was I wanted it to have I wanted it to be not in the middle because I wanted to check what different it will be if it's nearer or farther away from the drilling edge. But I haven't put this into this presentation for today. But I already checked it out, and it really makes a difference in most times. And so with this results, I can later on define which dimensions of ring gap is needed with the different ceilings.
Okay. So it's fine because it's reality. In reality, it will not be in the center, of course.
Yeah.
Okay. Thank you very much. And now I would like to ask also other chairmans, Olivier or Vladislav, if they have some questions.
If you don't mind, I have some, maybe not questions, but some adjustments of your presentation.
Yes, of course.
Yeah. You have different types of sealing, yes?
Yeah.
Your experiments were constructed on pipes and cables, yes?
Yes.
Yes. For each of these specimens, have you used all types of your sealings? If I don't mistake, five types of sealing, yeah, you use two special types. Yes, this slide.
It's four types of sealants, and so it's 16 penetrations, and I checked every line with each sealant.
With each sealant, okay. And about some conclusions or in a practical way. For example, you have some special sealant like Hilti acrylic and Hilti another another mixture, and you have the easiest way to seal with gypsum or stone wool. And in practice, is it better to use special mixture, or we can use only stone wool, for example, or gypsum, like a standard way in every building, for example? Because these mixtures, I think, have a high price.
I don't know if I really got a question, but I didn't check it out so far which sealant is the best. But in fact, it's not really representative to check just a special filler of one company. I would have to check some other special fillers with intumescent materials from other companies. But gypsum and stone wool is quite defined, and everyone knows what stone wool is. So yeah, sometimes it would be easier to use stone wool just because it's defined, and I would have to check if other intumescent or acrylic sealants work as well. But you're right, they are more expensive, but maybe it's easier to get into the ring gap, and you can save a lot of time by installing.
Okay, I understand. It is like a future investigation.
Yeah.
Okay, so thank you. And Oliver, do you have some questions?
Yes, thank you, Peter. Just one question about the experiment. How do you control the fire during your experiment?
So we have this special testing furnace, and there are two plate thermometers in the oven, and they control the temperature, and the pressure in the oven is controlled as well.
Yeah. It's a control in pressure and temperature. Yeah, that's right.
Yeah.
And you follow the same procedure for all your tests.
I always followed the described heat curve, which can be found in ISO 834.
Okay, thank you.
Okay, so I would ask you, this is a part of your thesis, studies on conduit penetration through wooden components in case of fire, as I know, and what will be the next steps? What are you planning for maybe some further experiments or for the finishing of your thesis?
Yeah, the plans are to find the module thickness for different fire resistance durations, and in these modules I want to describe how approved penetrations can be installed and how the modules can be fitted in different timber, wall, and ceiling assemblies.
Okay.
And I want to describe some facilitations for single lines, how they can be sealed in easier ways without approved sealing systems.
Okay. And sensitive question, when you would like to finish your thesis?
I hope in the end of this year or in the beginning of next year.
Okay. So it's a very short time. So okay.
Yeah,
So in fact, congratulations, and so we wish you success in your final stage of your doctoral work, and so I think it will be very interesting result of your thesis.